So today it is our session 6, and session 6 is about the assignment of the load structural members as per UBC 97 and Binding Code of Pakistan, and then the selection of desired code from where you can select the desired code, and then analysis of model and discussions on the results. So let's move on to the first part, that is the assignment of the load. The first load is the superimposed dead load that we will apply on our model, and these loads are applied as per the requirement because there is no specific table given in any code that shows the value for the SDL, that is super dead load, that is also called a superimposed dead load. So for routine design practice, the following loads are used as SDL: 30 pound per square foot for 30 inch of tiles on all floors, right? And I have given some basic calculations. If some of the students don't know how to calculate this 30 PSF load for 3 inches of tiles on for all the floors. So let us take the tiles thickness as 3 inches. The density of the tile is 120 pound per cubic foot, and the area load that comes out to be 30. You can calculate that into density into thickness, right? So I have divided that 3 by 12 to convert into feet. So when you multiply this into 3 and then divide by 12, so it comes out to be 30 PSF. So you can find out this SDL load for any type of material, for tiles, for chips, or adhesive floors, and for any thickness. For example, this thickness 6 inches, 5 inches, that will be according to your requirement, right? And the second part is the 20 PSF load on all floors to incorporate the loads of the bricks or formwork, right? So this 20 pound per square foot load is taken to incorporate, because when you are constructing a home, or you are constructing a high-rise building, so for the partition walls, different bricks will be placed on the slab, right? So incorporate those loads of the bricks or the formwork for the another slab. So 20 PSF load is taken to be on the safe side. So a total 50 PSF load is to be used as an SDL on slabs, right? So let us go to the ETAB. This is our model, and because we have this SDL is same for the all floors, whether it is used for the offices, or it is residential, or it is commercial. So these superimposed dead load SDL will be same for all the floors, and we have all the floors have same thickness. So we will go to select and select this slab property, which is 6 inches, right? You can select all the floors like this, or you can use the other option by disappearing all the openings, walls, beams, and columns. Click on OK, and you have to select it from here, right? So in this way, you can assign the loads. So now how can we assign the loads? So we will go to the assign shell loads, and we will click on this uniformly distributed loads. We will click on this. So a window will appear. It first will say the load pattern name, which we have defined previously. So you have to select the load pattern from here. So you will select SDL, and you have to apply, enter the value, 50 PSF. That you must notice that the value you are using is matching with the units you are using in ETAB, right? So here we calculated our load as 50 PSF, that is pound per square foot. So we have to change the unit if this unit is not compatible with your values. So our direction is gravity. You can also select any direction if you are designing it, this shell for the lateral loads or water or retaining walls, which will be using in a few minutes. So for this, we will use the gravity, because the direction of the load will be in the gravity direction, and we will click on apply. So this load has been applied on all the floors, right? So you can modify by clicking on a shell, right click, and go to the load tabs. So you can see that the load pattern SDL is uniform and it has been applied as a value of 50 pound per square foot and its direction is gravity, right? You can verify the load on any shell by right clicking on it, right? The next one is the live load. Let us go to the live load. Partition walls. Let us complete this SDL, then we will go towards live load. So for the partition walls or brick wall loads, the partition wall loads are taken as a loads per running foot. In routine design practice, this load is taken as 1 kip per foot on beams, right? So this is the routine practice which we do in our design, but there is another calculation for how this 1 kip per foot is we obtain this. So let us take the wall thickness as 9 inches and the density of the brick is normally 120 pound per cubic foot, right? So load per foot will be equal to 120 into 9 by 12, that is 9 inch thickness. We convert into feet, and 11 is the height of the story. So we will get the load per running foot, that is 990 pound per foot, right? So to be on conservative side, for the simplicity, we take it as 1 kip. So it is equal to 1 kip per foot means 1000 pound per foot, right? So we take this on the beam to incorporate the partition wall loads, right? So this is the first case. Now, if walls are not resting on beams and these walls are resting directly on the slab, so what should we do, right? For this, you have to calculate the area loads, and for the area loads, you have to calculate the number of walls, their lengths and height. So that you have to multiply the thickness, length and height of the wall to calculate the total loads of that partition walls, right? And then you have to divide those load by the area or the panel on which they are resting. So the area load is calculated is equal to the density into height into thickness divided by area of the slab on which these walls are resting. So in our case, in our model, right, if you, let me stop this. And let me open that architectural drawing. So in that, I will show you that we have one panel in which we do not have these partition walls on our beam. Right, so this is our architecture drawing. So you can see here the washrooms, the partition walls are not resting on the beam. This is our grid, this is our beam. These are joining this column, this column, this column. So these walls are not resting on the beam. So we have calculated this number of the walls and then the length of this wall, and then we have to multiply the length of the wall and then with the thickness and the height of this story. So we will get the total load which will be acting on this panel. So you can do it by yourself, but let me show it as a demo that we have this length is equal to 6 feet 8 inches, but I have taken it 7 because we have in here we have 7 feet. This is also 610. So I have taken this length as 7 feet and this length. So I have calculated. So we have to calculate it manually with total length of this wall, and then you have to sum all of these length and multiply with the thickness and the height. So you will get the total load, right? So in our case, I have calculated the total length by calculating the length of each wall by summing the length of each wall. So we get 104 feet. and then calculate the total load. I have multiplied this 104 with the story height, which in which our case is 11, but is normally less than 11 because the sum of the depth is incorporated by the beam. But to be on the safe side, we will take it as 11, and the thickness of the wall is 9 inches. We were converted into feet, we divide by 12. So we our total loads are we are getting is 860 pounds, right? So you have to divide this total load by the area by this panel, which will be resisting these loads. So by dividing this area is 20 into 27 feet, right? So dividing this load by the panel area, we are getting 2 pounds per square foot, which is very less load. So to be on the conservative side, we will take 10 pounds per square foot, right? So this is the general design practice. I'm using these values. So because some of the students will be saying, how did you use this 10? So it is comes from the experience. When you have enough experience, you will automatically take this 10. You don't need to calculate all of these. So in initial stages, you have to calculate this length and this thicknesses and total loads and divide it by area. So you will get the actual load, right? So we will take as a 10 PSF load on this panel, and we will take 1 kip per foot on our beams. So we will go to our ETAB model again, and we will uncheck these floors, check on beams, apply, right? So now we will use this all story command, right? So this is all again, this is SDL, so it will be on all the stories except the roof, right? So we'll click on this, we will select all the beams, right? And we will go to design, frame loads, distributed, and we will select SDL, and this is direction is gravity, it is a force, not a moment. And these are for trapezoidal load, non-uniform loads, and in our case this is uniform. So we will add 20 pound per. This is in kip, so you have to give it. This is 0.02. It means 20 kip pound per foot, which is equal to 0.02 kip per foot. So click on apply. So loads has been applied on each wall. So let me change the units so you can see. This is, so it changes to feet and this is pound. So you can see that the loads are being applied as a 20 pound per running foot. Now the next one is the wall loads to be applied on the. No, I have assigned wrong. This is not the case. This is 1 kip per foot for the beam. That was for the panel, right? Kindly, if I'm doing something like that, if I'm applying wrong loads or something, kindly do remind me. So I have selected all the beams, go to assign, frame loads, distributed, and we will select SDL, and we apply 1 kip per foot, that is 1000 pound per foot. Now change the unit into kip so you can see it as a 1 kip. So this is 1 kip per foot, you can see on our beam. So you can verify it by right clicking on the beam and going to the load. So you can see that the load pattern SDL is 1 kip per foot. And this is the open structure parameter, which is normally taken by the ETAB itself, but we do not have any load pattern load combination of the units, so it will not be taken in the design, right? So this was the beam loads. Let us go to the our panel, which we have to apply the partition walls. So in our case, this the panel between EF and G, and on the right this is 1, 2, right? So this is E, F, and G. So you have to select in all stories. So total 28 shells are selected. You have to go to the assign shell loads uniform, and select the SDL and apply 0.02, that is 20 pound per square foot, or 0.02 kip per square foot. So click on apply. Right, so remember I have done it intentionally. When you right click on this, so it is showing you only this SDL, right? So let me change the units again. So this is only 20, but all the other panels are showing 50 because I have selected the value to be replaced, right? So if I select this again and go to the assign shell uniform, so you can see in this option I have selected the replace the existing loads. Previously we have assigned 50 pound per square foot for the tiles load, but you have replaced there, so there is only 20 20 pound per square foot. The 50 has been removed because you replaced. So you have to apply it separately. So add to existing loads, it will incorporate for the tiles as well as for the partition walls. So let us add it 50 and click on apply. Now it is showing 70 because now it is correct, because we have 50 for the tiles load and then we have 20 for the brick partition wall loads. So now this loads are okay, right? So you have to take care for the replace and add to existing loads, because many of the students complained in the previous courses that we have assigned 100 PSF load, but the software is showing you 50. What happened to another 50? So that case might have happened to that you have replaced that 50 with 50, so that is not showing you 100, right? So this was the whole story about the superimposed dead load. Now let us go to the live loads. For the live loads, you can select it from the building code of Pakistan, or you can see you use UBC 97 because building code of Pakistan and UBC 97 are the same. So you have to go through this table. Let us go through this table first. So it is showing different categories and then its descriptions, and then you have this uniformly distributed load. For the excess floors, it means for the office uses, its value in pound per square foot is 50, and for the computer library or for computer lab, it is 100 pound square foot. So you can select any of your desire. For example, let us see for the residential. For the basic floor area, it is 40. For the exterior balconies, it is 60. For decks and storage, it is 40. So you can select it. And the shops and the commercial areas floors, they are also included in the you can select the load for the residential building, that is basic floor area. So we will select for the shops is a 40 PSF. So here it is 40 PSF light load on the shops, and we have on the top of it is offices. For the office use it is 50. So 50 PSF for the offices we will assign in our model, right? So you can use for any of your desired category. If you are designing a school, for the school you can see the 16 number, that is school. The classroom you will take 40 pound per square foot load, right? So let us go to the tab again, and let's see our stories. So now in our architectural drawings, we have, this is our basement plan, but the slab of this basement plan is this ground floor. So we on ground floor we will take the load 40 PSF because these are the shops, and then again the first floor we have shops, we will take again 40 here, and then again in second we will take the we have offices from the second to top, we have the offices, we will take 50, right? So in these two floors we will apply 40 pound per square foot, and for the offices we will apply 50, right? So let us use the command similar stories, because I have told you that we will use this command as well. For the similar stories, you have to define first the master story. For example, let us make this ground floor as a master story. So you will say this is a master story, yes. So now you can assign different stories to this master story. So when you make changes on that story, so automatically the changes will be applied on the similar stories that you have selected. Now, so this ground is similar to first, so we will say this is no, and we will take it as a ground floor. So we will make it also no. So to make the list simplest, right? So now the ground floor and first floor, these are the shops. We will making changes only is one floor, so the similar changes will be applied on the second, on the ground floor, right? So the second one is the master for the all stories. We will select yes, and we, because the all stories from second floor to top floor, these are the same. So we will make the third to second and all of this to a second. So when we make changes in second floor, these similar changes will be applied on the all the stories. We'll go up to the top, right? So click on OK, right? So let us have a demo, then we will go towards the assignment of the load. Let us display all over, right? So let me select from all stories to similar stories, and I'm on the second floor. So on the second floor, it means if I delete something or add something in second floor, why it is not showing? So if I delete or add something in second floor, it will be applied on all story. For example, let me select these 3-4 panels and let me delete it, right? Go to the edit and delete, right? So these panels are not deleted only from the second story. It will be always also deleted from the all other stories that has been assigned as similar to second floor. If I go up to the third, you can see this has been removed from the third as well as from the fourth and up to the top, right? So let me undo this. So this is the way you can use this similar story command. So we will go to the ground floor, because in ground floor we have the same loads. So let us uncheck the beams, right? So we will select only this ground. So automatically the first floor shells has been selected because of this command similar stories. You will go to assign shell loads uniform, and we will select live 40 pound per square foot, right? So now let us go to the second floor, and we will select the second floor. So automatically all the floors that has been assigned similar to this are selected, and similar for the loads, that loads will be applied to all of these floors. We will select live and we will apply 50 pound per square foot. Click on apply, right? So all of these load has been applied on this shell. If you go up in all floors, these 50 pound per square foot load has been applied, right, due to this similar stories command. So this was the whole story about the live load. For the basic floors, now let us go to the live load for the ramp and for the parking area. So the live loads can be selected from the ASC 716 table 4.3-1, right? So this is a table. In this table, you can see at the end that vehicle barrier, walkways, and elevated platforms. Elevated platform means the ramps, and the vehicle barriers mean the parking area, and these are the walkways that mean footpaths or different things, right? So for this, the code suggests you to use the uniform code as 60 pound per square foot, right? So this is the value for the ramp and for the parking area which you will be designing in your structure. So if in our case we have this ramp, right, and this is parking. So we will take the parking load 60 pound per square foot on our raft when we will be modeling our raft, but in our ramp, on our ramp we will take 60 pound per square foot because this is the elevated platform. Recording in progress. So we will be taking, please turn off your mic, please.
Please.
अच्छा माइक ऑन दिया बंद की कल
احمد زي ما هلا احمد
So we will be taking this 60 pound per square foot on the ramp in this or ETAB model, and we will take this parking load 60 pound per square foot on a raft when we will be modeling our raft, right? So let us go to this model again, and we will select property slab section. We will select the ramp 9 inches. So ramp has been selected. So you can verify it by going into view and click on the show selected object only. So this ramp has been selected, right? So you can see the load has been applied in here, because let us see what property has been assigned to this. So right clicking on this assignment. So ramp 9 inches, because we have selected the use the window command for selection of all story. So now we have to delete this load, that is the live load. So we will select this and go to the assign shell loads uniform. So some things I'm doing intentionally, so you can learn how to delete or assign different loads or change the units. So you have to select the live and click on the delete the existing load and apply. So this load will be deleted. So let me undo this, because we have selected similar stories. We will select only one story. We will design delete the load only from this shell, because the upper story is similar to that, right? So let us select this ramp. You will go to assign shell loads uniform, and we click on the live load, and we will apply 60 pound per square foot, and the direction is the gravity. Click on apply, right? So 60 pound per square foot load has been applied. You can verify it by clicking on the ramp, and you can see the load, that is live load 60 pound per square foot. The 60 pound per square foot load is remain. We will apply that on the our raft in the modeling of our raft, right? So this was the ramp loads. So let us move towards the retaining wall loads. So it's a bit tricky. So it needs your total attention. And let us discuss this in our next meeting. That is, this Zoom meeting is about to end in 9 minutes. So I don't want to interrupt this explanation. So then let me end this part, and I will produce a new link for the Zoom, and we will share it on the WhatsApp, so you can quickly join it, so we can continue our session 6, right?